Today we will discuss on PAPR. What is PAPR? PAPR in OFDM signal is basically the ratio of the peak of the power and the average power of the transmitted signal, where peak of the power is means defined as max of xt square and average is expectation of this an average of xt square. Now, why is PAPR important in OFDM? Because in the OFDM PAPR causes nonlinear distortion, high PAPR, because due to this high PAPR, power amplifiers forced to move to the saturation regions from the linear region, and due to which the nonlinear distortion occurs, which is not acceptable. To avoid this, we have to power amplifier should use high backup. That means if it use high backup, that means it will lose its efficiency. So we can say that OFDM signal have high PAPR because they are sum of multiple sinusoidal signals. High PAPR causes nonlinear distortion in power amplifier, reducing efficiency. Power amplifier must operate with high backup, increasing power consumptions. The power PAPR is defined in decibels dB scale, that is a log 10 PAPR. Now, factors affecting the number of subcarriers. If the number of subcarriers is high, obviously the PAPR will be high. It also depends on modulation scheme. If it is a higher order modulation scheme, then obviously there will be higher PAPR. Also affects the phases of the subcarrier also. There are some typical PAPR values are given for different modulation technique. If it is a BPSK with 64 subcarriers, then PAPR is 7 to 9 dB. For QPSK signal, it is 8 to 10 dB. For 16 COM, it is 10 to 12 dB. For 64 COM, it is 11. So you can see if the order of the modulation increases, the PAPR is also increasing. Now, for accepted PAPR for a practical system, if we think about wireless communication standards as LTE 4G, it's less than 9 to 10 dB. For Wi-Fi, that is IEEE 802.11 A, G and N, that standards is 10 to 12 dB. For 5G and 6 to 8 in that. And for power amplifier, there is a constant. If the PAPR is less than 7 to 9, there is power amplifiers works efficiently. If it is higher than that, then it has to use that is a backup to reduce to avoid this nonlinear distortion. In that case, it has to compromise its own efficiency. Why is high PAPR is a problem? Is a power amplifier efficiency is high. PAPR forces power amplifier to operate in these linear regions with a high backup. Means basically what happens if this is a high PAPR, then the power amplifier moves to linear to the saturation region. In that case, to build there will nonlinear distortion. To avoid this distortion, the power amplifiers used to use that high backup. That means to bring the operating points from saturation to the linear regions. So if it is bringing the operating point from saturations to linear regions, so it will lose its efficiency. If the PA operates in nonlinear region, it causes signal distortion, spectral regrowth and interference, and also there will be a reduce in battery life. That I will try basically. This is given for understanding this characteristic of power amplifiers. This is the linear region, this is the saturation regions. So obviously it should operate within this region to avoid nonlinear distortion. If it somehow moves to the saturation, then the power amplifier uses its power backup to bring it to the linear region. We'll try to understand with some example. Effects of high PAPR on P amplifiers in OFDM, due to constructive interference of subcarrier, the signal has high peak values compared to the average, obviously, which is you can see in figure. This the red line is the average one, and due to the somewhere constructive, somewhere destructive. If it is destructive, it goes below. If it is a constructive, there some positive peaks are there. Out of these positive peaks, you may find this is the P1, this is the peak power. So this ratio, if I take this value, there is approximately 0.15, and this value is approximately 0.01. So 0.15 by, if we calculate 0.15 by 0.01, maybe approximately 25, which is in dB scale. It's around, so which is more more than the acceptable value. Okay. Then understanding power backup, that is input backup, basically is known as P saturation. P saturation means this is the saturation level. This is the saturation level, output power saturation. Okay. So P sat, P saturation minus P input, this is input backup, output backup, P saturation minus P output. So if there is a high PPR, high backup, and low power amplifier efficiency. Now see here, if power backup is applied, then PPA does not enter saturation region. So basically, even if it moves to the saturations, the power backup takes it back to linear region. So in that case, the efficiency will decrease. But if power backup is not used, then it will be moved to the saturation region. There will be clipping distortion, error vector magnitude, spectral regrowth is there, adjacent channel interference also is there. Let's take an example. Say power amplifier, the maximum power output is 20 dBm. FDM signal with PPR is 10 dB, and average power is 10 dBm. Okay. So if we see that with no power backup, so peak power would maximum 10 plus 10, that is 20 dBm, which is touching this maximum output power of this power amplifier, which may, that means the power amplifier already entered to the saturation region. So there basically there will clips, distortions will be there. But if you use say some 10 dB power backup, it may be not 10 dB, it may be some other value. If you take 10 dB, so this 10 dB input, 10 dB power backup means this 10 dB minus this 10 dB power backup will be reduced to 0. So that's what the first line input power reduced by 10 dB to 10 dB. Because if we use a 10 dB power backup, so it will be subtract this input to the 0, and then peak power is now, because 10 dB peak power, so 0 plus this average power, it becomes a peak. So since it is a total output power is 10 dBm, and that power amplifier output maximum output power is 20 dBm, so this one is less than this 20 dBm, so we are in, automatically the power amplifier is in the linear region, so there will be no distortion, but the efficiency is already compromised. We take the second example. See here the same problem, but just only the PA pair is changed from 10 to 12. So obviously that peak power, if we add these two, it will be 22 dBm. 22 dBm, which is greater than 20. That means it is in the saturation regions. Okay, so that means it's 2 dB greater than this 20. So backup at least 2 dB have to use to at least 2 dB. If you use 3 or 4 dB, then it may say 12. If I use say 4 dB, so 22, I'm getting 22. If it is a 4 dB, the power backup, so 22 minus 4, that is 18 dB becomes, which is less than this 20 dB. So if we use a 4 dB backup, then automatically the power amplifier operation moves from saturation to the linear region. So how to prevent these saturations? A power backup we have used. Other techniques are PAP reductions. That is, one is clipping of and filtering, selective mapping, partial transmit sequence PTS, upon reservations and compact. It is the techniques to reduce PAP.